If astronomers have discovered something with the James Webb Space Telescope, what is it? Are we really the only ones in the universe? The James Webb Space Telescope has made some amazing discoveries that resemble signs of life and are far, far away from Earth. These findings bring us closer to answering the age-old question of whether we are alone in the cosmos. Many people have long searched for life beyond Earth, with countless books, movies, and theories exploring this topic. We have always been curious about our place in the universe and often feel a sense of loneliness, as if we are constantly searching for a companion, no matter how alien they may seem. We may even be getting closer to the answers we've been seeking. But are they really that frightening? The latest discoveries in galaxies and planets searching for terrestrial life may reveal something we are not prepared for. Scientists have found something that could be one of the most important discoveries yet. When the James Webb Space Telescope was set to launch in 2021, an interesting question arose regarding our technological capabilities. Would our telescopes be able to detect artificial lights on other worlds in the future? The closest exoplanet to Earth, Proxima b, lies in the habitable zone of Proxima Centauri, a red dwarf star 4.25 light-years away. Although Proxima b is 20 times closer to its star than Earth is to the Sun, it is believed to have a permanent day side and a permanent night side, similar to how the Moon always shows the same face to Earth. An advanced civilization on Proxima b could use photovoltaic cells to convert starlight into electricity and transfer heat and power from the day side to the night side. In a study that included researcher Manasvi Lingam, it was shown that future telescopes could detect solar panels covering much of Proxima b's daytime side. This suggests that we could search for artificial lights on exoplanets like Proxima b that might harbor life, thanks to the advanced technology of the James Webb Space Telescope. By 2024, the James Webb Space Telescope could have detected the light we have been looking for, thanks to its increased sensitivity and remarkable capabilities. This discovery could accelerate the next big step in our evolution. But first, we need to learn more about planets and exoplanets to understand how this is possible. The JWST's mission is to uncover what Proxima Centauri b is hiding. Ever since humanity became self-aware, we have shown interest in the nature of the universe, trying to answer difficult questions about our existence, origin, and destiny. Although technology is constantly advancing, one might wonder if we are truly any closer to answering these questions. A philosopher might argue that our knowledge is still in its infancy, while an astronomer would be eager to discuss the latest cosmic discoveries. The average person may not pay much attention to these scientific tools, but they are a true testament to human evolution, allowing us to reach beyond our world and into the vast cosmos. Scientists and researchers have found a way to use technology for this purpose, and a recent discovery, possibly lights from a planet light-years away, is thanks to a specific piece of technology: the James Webb Space Telescope. This telescope, made possible by the efforts of space pioneers, is helping to answer timeless questions about our existence in the universe. Are we alone? Where did we come from? Where are we going? The James Webb Space Telescope, an infrared tool for stargazing, has already begun answering some of these questions. Proxima Centauri b, sometimes called Alpha Centauri Cb, is a super-Earth orbiting an M-type star. If this seems complicated, don't worry. This explanation will help clarify it. Super-Earths are planets larger than Earth, but smaller than ice giants like Neptune and Uranus. These planets, unique in their rocky or gaseous compositions, range in size from 2 to 10 times the mass of Earth. Proxima Centauri b is both a super-Earth and an exoplanet, meaning it exists outside our solar system. The first signs of an exoplanet were detected in 1917, although they did not generate much interest at the time. Scientists were truly intrigued when they made their first confirmed detection in 1992. By 2003, another exoplanet, distinct from those found in 1988 and 1989, was confirmed. As of April 1, 2024, there are 5,653 known extrasolar planets in 4,761 planetary systems, with 89 of these systems confirmed to contain more than one planet. These fascinating discoveries often revolve around M-type stars. Before discussing these stars further, it is important to understand what a red dwarf is. The name red dwarf comes from the fact that this is the smallest type of star on the main sequence and the most common in the Milky Way, as well as being the closest to the Sun. Red dwarfs do not emit much light, making them difficult to detect despite their prevalence. Depending on their brightness and size, they have different classifications and names. For example, M-dwarf or M-type main sequence stars have a maximum temperature of 3,900 Kelvin, which defines their characteristic. We know that Proxima b has a mass of 1.07 times that of Earth and completes an orbit around its star in just 11.2 days, whereas Earth takes 365.25 days to orbit the Sun. Proxima Centauri, the star of Proxima b, is surprisingly dim, only 0.16% as bright as the Sun across the entire electromagnetic spectrum and even dimmer in visible light, emitting just 0.056% of the Sun's brightness in that range. More than 85% of its energy is emitted as infrared light. The discovery of Proxima b, which orbits at a distance of 0.04856 Australian dollars from its star, was made public in 2016. Why is there so much interest in Proxima b, given that the universe contains millions of stars, planets, and galaxies? What makes Proxima b special is its proximity to our Sun, as it is the closest known exoplanet at just 4.2 light-years away. On a cosmic scale, this is relatively close. Additionally, Proxima b is part of the Alpha Centauri triple star system, one of the brightest in the night sky, ranking third after Sirius and Canopus. The most intriguing aspect of Proxima b is its potential habitability, as it lies within its star's habitable zone. This opens up many possibilities, which is why astronomers are so eager to explore the limits of what this planet may offer. The James Webb Space Telescope, JWST, has four primary goals: to search for light from the first galaxies and stars that formed after the Big Bang, to study how galaxies form and evolve, to investigate the formation of stars and planetary systems, and to better understand the origins of life. From the search for extraterrestrial intelligence, SETI, to exoplanet exploration, these projects are bringing us closer and closer to discovering extraterrestrial life. With JWST continuing its exoplanet research, we may soon find the answers we've been looking for.